Our design we chose was based around simplicity, with everything from our drivetrain to our wheels to our competitive strategy. Our drivetrain consists of only 2 gears to limit all of our power losses and keep it on the simple side. We support each of our stationary axes twice in order to limit the cantilever effects on the wheels. The most prominent feature of our robot are its large wheels, which give it more clearance and make it easier to get over pipes when we try to get up the ramp. We designed the fin to keep the weight above the wheels to give enough clearance to get over the pipes and to keep friction low. We try to make the lightest possible robot with the majority of the weight over the wheels to create small amounts of friction while still giving the wheels enough traction.
In addition to the planetary gearbox, we used one 16-48 gear connection on each wheel, giving us a gear ratio of 4. Most teams from last year use a gear ratio of 3, but we chose a larger gear ratio in order to account for our larger wheels. In our manufacturing process, we tried to make the parts as precise as possible to minimize losses of power and the chance of anything to slip, misalign, or break.
Although our wheels are technically cantilevered, we tried to mitigate this by supporting them twice and keeping the length of the exposed beam to a minimum.
Our primary strategy was to focus only on getting up the ramp as many times as possible during the competition. Our secondary strategy was to make it harder for other teams to score over the balls by pushing the balls off of their pedestals.
One thing we learned is that bigger is better. As you can see here, our big wheels help us navigate the pipe ramp, as the increased size makes it easier to overcome the humps. The low weight of our robot and the positioning of both the motor boxes and fin keeps the majority of the weight above our wheels and the center of mass close to the front of the robot, giving the wheels maximum friction with the ground to provide traction. Within the drivetrain, we reamed and greased the holes to reduce power losses to friction. We also used a dead axle to minimize friction losses at the wheels.
The second lesson we learned was to always make extra parts. Shortly before the drivetrain test, we actually dropped our robot, but luckily thanks to planning ahead, we were able to put on a spare wheel minutes before the end of lab and complete our test. Thanks for watching.
Wish us luck.
And we are the Finntastic 4.
But Matt, there's only 3 of us, not 4.
Let's go with it.